Good evening. Last month we talked about the probe LCROSS, which landed on the moon inside the crater Cabez in the hunt for water. Well, Christmas in America, with one of the world's big telescopes, I was on the beach at Celtic. Neither of us saw anything, but there have been interesting results since then.
Yes, fantastic news, in fact. So remember, LCROSS had two parts. There was the rocket that hit the bottom of Cabez, that's where most of the impact came from, and then flying a few minutes behind was the shepherding spacecraft, LCROSS itself. And we've just had the first proper results from that spacecraft, which flew through the debris that was thrown up by the rocket impact. And the good news is that NASA got what they were hoping for, what I know you were sceptical about, which is the definitive sign of water at the bottom of Cabez.
I'm afraid I'm much less excited than you are. Certainly tiny icy particles, almost certainly dumped there by a comet. That is not lunar water. The moon is as dry as a bone.
Well, it's true that this isn't anything to do with the formation of the moon, but what we have is a deposit of water on the moon. Now, it's clear that this isn't liquid water. There's no way you and I are going swimming in the bottom of Cabez anytime soon, but there must have been ice down there, and quite a lot of it. In fact, about 24 gallons was detected, so that's a bathtub full. But remember, that's just from one impact, and not from the whole crater. So there must be much more down there and in other similar craters down at the moon's south pole.
Well, I wonder. We must wait and see. From the moon to the sun, and a huge solar tsunami. And that must have been a spectacular thing.
Yes, it's incredible. These are results from the STEREO spacecraft. And when scientists first saw something like this, I don't think they believed it. They thought it was an instrument glitch or some sort of error. But it's true. What you see here is a large amount of material. This is a wall of material on the surface of the sun, 60,000 miles high, moving at about 500,000 miles per hour. So it's this shock wave spreading across the sun, and it's quite a dramatic, spectacular event.
And the sun was also sending out clouds of material, and there had been brilliant northern lights or aurorae. Not from England, as far as I know, certainly from places like Norway.
Yes, and speaking of aurorae, if you can't see them from down here in Selsey, we've had a spectacular view of the northern lights on Saturn from the Cassini spacecraft, which sent back this amazing video. So you're looking in visible light. This is roughly what the eye would see, although obviously enhanced. You can see the dark part of the planet there on the night side. You can see this flickering of the lights caused by the solar wind impacting Saturn's magnetic field. It's absolutely beautiful, isn't it?
It certainly is, and Cassini has certainly exceeded all expectations. For example, Enceladus, with fountains of water ice coming from its poles, they simply shouldn't be there.
Yes, these fountains have been keeping us entertained ever since they were discovered right at the beginning of Cassini's mission. But these new images from Cassini show exactly what's going on. They're absolutely stunning. Not only can we see the vents which shoot out this water, we see these dramatic images of the stream silhouetted against the sunlight there. But if you look right down, we can see the areas from which the water's coming. You've got this very complicated landscape with all sorts of ice features and cracks, and it looks like a very dynamic and active place, don't you think?
And it's a tiny place too, and there's much more water there than there is on the moon.
Certainly, I agree with that, Patrick. That's definitely true.
And then, of course, we have this new ring of Saturn, 8 million miles from Saturn, different from the other rings, and not visible really, invisible at all.
No, it was discovered by the Spitzer Space Telescope looking in the infrared, and as you say, it's very different. It's much thicker and much wider than the other rings, made of darker material, definitely. That's why it was only discovered in the infrared.
And very, very verified, but it solves one major problem. The problem of the satellite Iapetus, much closer into Saturn, half bright and half dark. Why was that so? We've never known. Well, now we do. The ring particles are wafted in from the Phoebe ring onto Iapetus, and the ring particles are going around in a retrograde or wrong way direction. Iapetus not, therefore they meet head on.
It ploughs straight through them. That's certainly the most convincing explanation for Iapetus's dark side that I've heard. Of course, we've still got to explain why it has this amazing ridge round the centre. It has this enormous wrinkle. That's still a mystery.
It's a weird world. Now let's come much closer in, shall we, to the planet Mars. The two rovers, Spirit and Opportunity, have been doing wonders, and very sadly, Spirit is now in trouble.
Well, Spirit's been stuck since April, in fact. It ran over a dust-covered crater and has sunk down into the soil. It's had a lot of trouble trying to extract itself. However, the team have begun efforts to try and extract Spirit from the trap that it's got itself into.
So far they had no luck, but we hope they will. Opportunity, of course, is going strong. So certainly both these rovers have lasted for far longer than their makers dared to hope. They're quite incredible things, aren't they?
They are, and Spirit has moved a few centimetres in the last few weeks, so they're beginning to edge it out of the trap. I'm not ready to write its obituary just yet.
No, nor am I, and I hope we don't have to. Now this programme's called The Winter Sky, and certainly the stars of winter are more brilliant than those at any other time of the year. So let's now join peace in the garden.
I love the December night sky, and the reason for this is that it gives such a long period of darkness. Go out early evening, look up, and there are the stars of autumn shining down on you. Go out in the early morning, and there are the stars of spring shining down on you. But right in the middle of the night, that's when things get truly spectacular, because that's when the winter constellations are seen at their best. Now, winter for me means Orion the Hunter, a very distinctive pattern of 7 bright stars. You can find Orion rising in the east at about 7 o'clock mid-month. But if you give him a few hours to get up a bit higher, then we can use him to best effect. Now, Orion is formed by 2 stars at the top, 2 stars at the bottom, and 3 stars in the centre, which form a very distinctive straight line. The star in the upper left corner of Orion is orangey in colour. This is a star known as Betelgeuse, and it's a red supergiant star, a truly massive star, about 800 times the diameter of our own sun. Now contrast it with the star in the lower right corner of Orion, which is known as Rigel. This is a blue supergiant star, and when you look between them in the night sky, you can definitely see there is a colour shift. Okay. So if we go right into the centre of the constellation, that's where we have this very famous straight line known as Orion's belt. Now if you look at Orion's belt, say with a pair of binoculars, you'll see that there are lots of faint stars around it. And this is because the Orion's belt marks the direction of an open cluster of stars known as Colander 70. Now, no self-respecting hunter should be seen without a sword, and Orion is no exception. If you look below Orion's belt, you can see a faint line of stars hanging down, and this forms his sword. Now look at this region with a pair of binoculars or through a small telescope, and you can see there is an area of gas and dust there which is glowing, beautiful swirling clouds. And this is known as the Orion Nebula, and it's a region where stars are literally being born. The hot young cluster stars in the centre of this nebula actually cause the gases of the nebula to become excited, and that's what we can see. Now Orion is a fantastic winter signpost to some of the other constellations on view. If you follow the belt stars up and to the right, you eventually come to a fairly brightish orange coloured star known as Aldebaran. Now the name Aldebaran literally means Eye of the Bull, and that's a bit of a clue to which constellation the star lies in. This is the brightest star in the constellation of Taurus the Bull, and to find the bull's face, if you look to the right of Aldebaran, you can see there is a V-shaped cluster of stars known as the Hyades. Now if you follow the belt star of Orion up through Aldebaran and keep going, curving it slightly as you go, you finally arrive at another very distinctive cluster known as the Pleiades, or Seven Sisters. With the naked eye, if you get a really clear dark sky, have a look at them and see how many stars you can count there. You might be surprised. Now if we return to Orion, we can follow the belt stars in the opposite direction down and to the left. If we do this, we come to a very bright star known as Sirius, the dog star. In fact, this is the brightest star in the entire night sky. It's also the brightest star in the constellation of Canis Major, the Great Dog. Now from the UK, Sirius doesn't get very high above our horizon, and its light therefore has to pass through some rather thick and turbulent layers of atmosphere. As it does this, the star appears to twinkle quite violently, and you often get flashes of red and blue coloration with it. It's quite beautiful to watch. Now if you go up from Sirius and over to the left, you eventually come to a star which is sort of in an area of sky more or less on its own. And this star is known as Procyon, and it's the brightest star in the constellation of Canis Minor, the little dog. Now if you join a line from Sirius to Procyon, and then from Procyon to Betelgeuse, and then down to Sirius again, you form an unofficial pattern in the night sky known as the Winter Triangle. Okay, We return to Orion again. We can use him as a signpost once more. If you go from the star in the bottom right-hand corner, that's Rigel, draw a line through the star in the upper left-hand corner, that's Betelgeuse, and keep going until you come to a pair of stars. Now this sounds a bit of a strange thing to say because any two stars are going to make a pair, but these two really do look as if they belong together. And so they should, because these are the two brightest stars of Gemini, the heavenly twins. The upper star is known as Castor and the lower star is known as Pollux. Now, there is going to be a very special event happening in the middle of December. We have a meteor shower known as the Geminids. And the Geminids is so called because the meteors which occur from it appear to emanate from a point in the sky known as the radiant, which is located very close to the star Castor. Now, if you go out on the night of the 13th, 14th of December, you stand a very good chance of seeing a Geminid meteor streaking across the night sky. We have a number of benefits this year with the Geminids. For one, the moon is going to be completely out of the way, so the sky should be very, very good and dark. We also have the fact that the radiant, the position where these meteors appear to come from, should pass more or less overhead at about 2 o'clock in the morning, and this is ideal for meteor shower watching. So give yourself plenty of time on the night, use watches of at least 30 minutes, say, go out in the middle of the month, look up skyward, and see if you can see one of these beautiful Geminid meteors streaking across the heavens.
Back to the garden, into my study with Chris and with our guest, Professor Bob Nichol. Welcome, Bob. I know you're involved very deeply with a project called SLOAN, so can you please begin by giving us a brief rundown on SLOAN?
The SLOAN Digital Sky Survey started taking data in the year 2000. At the time it started, it was the world's biggest camera, so it's a very, very large digital camera. It has a 142 megapixel camera in the optical, and in addition it has 2 spectrographs. So it's able to take very large images in one shot of the sky, much greater than the diameter of a moon. That allows it to wallpaper the sky, because it can take many images and put them together, and thus do a whole digital image of the night sky. So you can have that in your computer and be able to dial up any position on the sky and get an image for it.
And similarly, you can cover the whole sky quickly, but you can also take lots of spectra at once as well.
Exactly. In the original SLOAN, we had both a digital imaging camera and a spectrograph. In SLOAN 3, we're actually getting rid of the digital camera because we don't actually need it anymore, and we're going to concentrate on the spectroscopy, as you point out. What's still unique about the SLOAN hardware is its ability to do massive amounts of spectroscopy across this large field of view.
So you take the light from an object and split it up into its wavelengths.
Exactly. So when you're looking at those wonderful images and you make them up with red, green and blue, that's sort of a spectrum of 3 colours. Imagine now having a spectrum of 2,000 colours, and that's really what we have, is you split the light up into all its little individual colours, and you're able to see quite subtle features. You're able to see atomic features, so you can tell what's in the object you're looking at. You can tell what atoms are in the object, and that's why spectroscopy is so important. It's like chemistry. You're doing chemistry on these objects.
What will SLOAN tell us about the stars in our galaxy?
So Patrick, for SLOAN 3, what we're planning to do are 2 new surveys of stars in our galaxies. One is Segway, which is a continuation of the optical spectra of stars in the outer regions of our galaxy. But the really exciting one is something called Apogee, and this is a new survey using a new infrared spectrograph. And what Apogee will do for the first time is be able to look at stars in the disk of our galaxy through all that muck and dust that is in the disk of our galaxy. And as you know, that extinguishes optical light, so you can't see very far in the optical, but in the infrared you can see much further through the disk of our star. And in fact, we hope with Apogee that we'll be able to look at stars in the bulge of our galaxy. So we'll be able to measure the dynamics and also the spectral characteristics of stars in our bulge.
So the bulge of the galaxy is the blob at the centre, right?
Exactly.
If you imagine, I always think of your analogy of 2 fried eggs.
2 back to back, yes.
So if that's true, the bulge must be the yolk, right? right? The yellow bit.
Yeah, and in fact, that analogy is perfect because the yolk is yellow, and yellow stars tend to be old stars, right? And the fried disk bit, the white bit, is the disk, which we think is made up of young stars, which typically are whiter and bluer. So actually, the fried egg analogy is perfect.
And all we've looked at so far with the optical in our galaxy is the white bit.
Sure, or straight out of the white bit. So we've looked out of the plane of the egg. As you know, what's kind of interesting is that big blob, or that yolk of old stars, that bulge of stars in the center. And if, again, our theories of galaxies are correct, that bulge formed first. But it's extremely difficult to look at the bulge because you have to look straight along the galaxy, straight through this disk that's made up of dust and muck and rubbish that is in our galaxy. And you can do that much easier in the infrared. So SLOAN will do a survey of infrared stars along the disk of our galaxy. What's very interesting is potentially we may find very metal poor stars. And those are the types of stars that could have been formed from the very first stars in the universe, something called population 3 stars. And again, you need to look at a lot of stars to find these one rare objects.
How old are they?
So the population 3 stars could have literally formed just after the cosmic microwave background, which is about 300,000 years after the Big Bang.
So more than 13 billion years ago.
More than 13 billion years ago. So these would be the oldest stars made up of the pristine material that was around just after the Big Bang.
We should talk about SLOAN's new role as a planet hunter as well, because that's an obvious advantage of this wide field of view that you've been describing. We can go searching for planets as well.
So this is the MARVELS project. MARVELS is again another new spectrograph that is using the SLOAN telescope. It can observe 120, or will do soon, 120 stars simultaneously. And the beauty of MARVELS is it makes incredibly accurate spectral measurements of those stars. And what it looks for are the wobbles. It just looks for the radial velocity wobbles of those stars.
So this is the star being pulled by planets that are around
exactly.
it.
So we expect SLOAN to find about 200 Jupiter-like objects, and hopefully those solar systems contain Earth-like objects, and so there'll be a wonderful opportunity to try and find other planets, other Earth-like planets out there.
If you don't, the yoke will be on you. I'm sorry. Well, SLOAN has made great contribution to cosmology, and is still doing so, of course, among all other programs.
The advances now that they've made in the hardware to the SLOAN Digital Sky Survey allow us to make a quantum leap jump outward, so further away from us but closer to the Big Bang, and now study the distribution of galaxies further away from us and add another slice to the cake, if you want to think of it, about the distribution of galaxies between us and the Big Bang.
So, Bob, how long will SLOAN continue to operate?
It's now 2009, and the SLOAN will carry on. We've got funding until 2014, so it'll definitely carry on until then. Maybe there'll be a SLOAN 4. It's still very unique hardware in what it can do, and maybe it will keep me going until I retire. So you'll just have to keep asking me back, and I'll answer that question in stages.
Well, thank you very much, sir. Thank you very much, Bob. Thank you, Chris. So this is our last programme of 2009, so I hope it's not too early to wish you all a very happy Christmas and New Year. And lastly, don't forget the tiny partial lunar eclipse on New Year's Eve. So until 2010, goodbye.